Welcome to the DBA Fundamentals Virtual Chapter Meeting for January. Today's presentation is entitled Performance Tuning Pit Stop for DBAs. It will be presented by Ayman Al-Ghazali. Sorry if I messed that name up, Ayman. I'll be turning things over to Ayman in just a minute, but I wanted to bring a few things to your attention. PASS, we want to give a big shout out to PASS. They have virtual events, local user groups, summits, and other popular events called SQL Saturdays. These events are around the world and are held in locations that are sometimes in your own backyard. This January presentation, or SQL Saturday, is actually in my backyard of Nashville, Tennessee. You can come and visit. There's free sessions going on. All day Saturday. There's pre-cons, which happen the Thursday and Friday beforehand, and we have the DBA Fundamentals chapter has the honor of being able to give out a discount code that will give you a 20% discount off the pre-cons. If you would like to sign up for these, you can go to www.sqlsaturday.com and use the discount code DBAFunVC, and that will give you 20% discount to the pre-cons. Tamara Clark is the one that is organizing it, and if you have any questions about it, you can email her at tamara.clark@gmail.com. My name is Mike Brumley, and I am one of the vice presidents of the DBA Fundamentals chapter. If you would like to contact myself or any of the other virtual chapter leaders, you can find our contact information at fundamentals.sqlpass.org and selecting the About Us tab. Our next meeting will be January the 20th, and it will be presented by Kimberly Tripp. She'll be presenting a session called Statement Execution and the Plan Cache, so be sure to sign up for that. This session is being recorded and will be available in our archive session, hopefully within the next couple of days, but within a week for sure. And we should be able to get the slides and scripts from Ayman to put on that site as well. That's all the housekeeping I have. Today, again, we have Ayman Al-Ghazali, and he will be presenting Performance Tuning Pit Stop for DBAs. Ayman is a passionate SQL Server DBA developer and business intelligence developer. He is currently a senior consultant with Microsoft and lives in the Washington, D.C. area. Over to you, Ayman.
Thank you very much for that intro. Good morning, good afternoon, good evening to everyone, depending on where you are. I'll get started right away. Just want to make sure that you see my screen first. You good on the screen sharing?
I can see it, but I can see...
Should be able to see some...
Yeah, that looks good.
All right, there we go. Okay, so let's get started. And I will have the slides and code on my blog. I actually put them up before we started. So let's get started. So let's talk about today's goal. Basically, one of the goals is to make your system faster with as little downtime and the least amount of impact in terms of re-architecture and coding. So what this means is we're going to try to make your system faster in a transparent manner. So you don't have to change any code or do anything that would affect the user, although I highly recommend using a maintenance window for some of the stuff we're going to discuss. Also, trying to make you a performance tuning ninja, so hopefully you're going to be a lot better at performance tuning after this. And just remember this rule, test twice so you don't break production once. Today's agenda. First, we're going to do a little bit of a check engine. We're going to use something called PAL tools to get a baseline for the system. Then we're going to discuss files and file groups. We're going to talk about configuring TempDB. We're going to talk about all these different acronyms, IFI, VLF, probably not WTH. And then I'm going to briefly go over some other considerations. So let's jump right into this. So one of the things that DBAs rarely check on their system is the power settings. And the power settings is a setting in the operating system, so Windows Server at this point, and BIOS. And a lot of times the Windows default power settings is set to, it's not set to maximum performance. Setting it to maximum performance as a group policy is great for servers, and you should make sure that your BIOS is updated so it doesn't do any type of power saving stuff. So what happens with power saving is it cycles down your CPU, so it doesn't allow it to perform as best as it can. And this is a very simple setting to change, and you can get maybe 20% performance increase. The other thing is a lot of times when we install SQL Server, we don't check the maximum memory settings. So I put a little formula on the screen here, and you can choose whichever way you want to go about slicing your memory. But the point of setting a max memory for SQL Server is there are other applications that may be running on there, and your operating system needs memory. So if you do not set that max and SQL Server takes all the memory on the server, the operating system is going to start eating up memory that it needs if there's any memory pressure, which means it's going to randomly drop pages from memory, and those pages may be actively used. And you should also take into account that if you have SSIS, SSAS, or SSRs, or other services running, that you're going to have to tone down the amount of memory that SQL Server uses. Finally, you want to check the cluster disk size, or what's known as allocation units for a disk. Make sure that they're set to 64K. It's a little harder to do once you have data on disk, and I'm not going to discuss that in detail. We have a whole other session on the DBA Fundamentals chapter about internals, so I'd highly recommend you check that out after this. You want to make sure that auto shrink and auto close is disabled for all of your databases. Shrinking is not a good option unless you really need to do that, and definitely using auto close is not good at all. And do not disable auto grow on any of your databases, because you want to make sure that if your database is growing, that it has enough room to grow, but do not rely on it. And the same goes for your log file. Okay, so let's talk about baselining with the PAL tools. Why would you want to have a baseline? Because there's always that annoying person that says they want proof for something. So that's one reason to get a baseline. But baselines also help determine the effectiveness of your tuning. So you can prove that the activity you've done in performance tuning is actually working. And working in what aspect? Is it working to make your disk faster, or using less space in RAM, and so on and so forth. It also helps you determine, your activity in the future and how your server is behaving. So if you have a baseline for today, January 6, 2015, maybe in a month you do another baseline, and then you can determine how your data is growing. And from that, you can start to request more hardware, or even DBAs or developers on the team if you need that. So baseline is a good way of adding more financial stuff to your system, whether it's hardware or numbers. And you can also call yourself a scientist afterwards. So, but that's optional. So I'm going to start by going off into demo land here, and I'm going to use the PAL tools. These are free tools that you can download. Just use your favorite web browser, go to the web page here, or Google it or Bing it to search for PAL tools, and then download it. Just piece of advice: make sure you get all the prerequisites, or things won't work. So once you install it, you get this fancy icon here, and you don't get that many references. Then you open it up, and it's a little confusing at first. What you want to do is you want to go to this tab that says threshold file, and you want to pick SQL Server 2008/2000/R2. And this should work for 2012 and 2014 as well. And what you're going to do is you're going to export to a perfmon template file. Right, so I'm going to save this to my desktop. DBA run test. And once I hit save, it's going to ask me for the name of the server. So if I'm trying to analyze the default instance, I'm going to leave this blank. If I've named instances, then I'm going to name them. And for clusters, you need to name the name of the FCI. So I'm going to leave this blank. And as you can see, I have this XML file here. So I'm going to close the PAL tools for now. I'm going to open perfmon. And what I'm going to do is I'm going to create a new data collector set. Okay. And I'm going to create it from a template. And I'm going to click Browse. I'm going to go to that XML file that I created. Click Open. Next. And I'm going to select where I want my performance tuning log saved. Save and close. And here I have a new data collector set. One thing I will recommend is that you go to Data Manager here, and you may need to increase the maximum set here, because your system may have a lot of data that's recorded. So just keep that in mind. These maximums work for my system, but might not work for yours. So what I would do here is I would start running this data collector set and let it run for a given time, maybe a day, or however long I want to benchmark. And once it's done, what I will do is I'm going to take that log file that it produces and I'm going to put it into the PAL tool. I'm going to open the PAL tool again. I'm going to go to counter log, and I'm going to find my perf log here. I'm going to take an old one that I've already completed before. And what's cool about it is you can restrict the date and time range that you want to do the analysis over. So I'm going to click next. I'm going to take the whole log. And under threshold file, that's the same tab we were at before. So we're going to make the same selection here for SQL 2008, 2002. So what's going on is this XML that I exported has become a template for perfmon. And it's going to record the data for those counters, and then it's going to put it in that log, which I plugged into the program here. And then I'm going to say I want to compare that log against this threshold file. And when I click next, there's a couple questions that ask me PLE health, which is page life expectancy. SQL Skills has a good article about what your PLE should be. I believe the author was Jonathan. Can't really pronounce his last name. It starts with a K. That's as best as I can get. He'll let you know what's recommended for this day and age. Back in the day it was 300, but that's not a recommendation that really holds true today. You're going to select your operating system. You're going to select the amount of physical RAM that you have in gigs. So I only have 1 gig. And this last variable here is mostly for 32-bit systems. Hopefully no one has this 32-bit system out there. So I'm going to skip it for now. It's going to ask about the output options on the next tab. I'm just going to select the automatic intervals, which is just going to slice up my counter into 30 time slices. I can also choose to do all the counters, which is going to take a significant amount of time. And now I can select on the next tab the file output. I can pick XML or HTML, whatever I want. This Q tab here just kind of shows a summary of what we've been doing, and then when I click next, it'll ask me if I want to execute. And I can increase the number of threads if I want to execute this faster. I would recommend that you create the report using this execution method on something other than your server, maybe your desktop or something. I'm not going to run this now because it takes a while, but I have a PAL report that's ready, and I'll go through this briefly. So what the PAL report is basically a web page. And at the top here you'll see all of the events by chronological order. And as I go down, it starts to separate them by different counters. So these are all my memory counters, for example. These are all my network interface counters. These are all my process counters, and so on. And as you go down, you have the specific SQL counters. And some of them are more valuable than others. Let me try to find something here with a lot of alerts here. Let's say latch waits per second. And when I click on it, it's going to go to the section of the report for that specific counter. And what's interesting is it'll always tell you a description up here of what the weight does. And then it'll give you the counter and what's, what is the recommendation, what are the highs, lows, min, max, so on and so forth. And some of these counters, let me see if I can find them here, will have a lot more detail. Have a lot more detail, and they'll have web links to more detail about that counter. So you can start to understand what the counters do. And some of these counters will be irrelevant by themselves, but what PalTool will do is it'll compare it to other counters that make sense, like batch requests per compilations, for example. So I'll let you all dig into that a little bit deeper, and I'm going to go back to these slides. Do you have any questions?
We have a couple. Does the PAL need to be installed on the SQL Server or on which it is used, or can it be installed on a remote server?
It can be installed on a remote server. That's a great question. The only thing that you need on the server that you want to track is that data collector set on perfmon. And then you can do all of the analysis off of another server. And I would highly recommend that you do the analysis on another server.
Is it resource intensive?
The PalTool, a little bit. But perfmon, I think it's good to run on a production server. So do the perfmon on the server, obviously, to get counters, and then take your PAL, PAL analysis off of the server. I'm going to go on. If we have any other questions, I can get them later. So let's talk about files and file groups. So modern database management systems have multi-threading capabilities, which means that you can have multiple processes or workloads running simultaneously. So the database engine, SQL Server, can take advantage of that by allowing multiple working processes to use one or more threads to complete work. Now, what does that mean for us? It means that file placement, size, and the number of files can make or break performance. And I'll get into that a little bit deeper as we go along. Data and indexes can be distributed across different file groups. So you can have data sitting on one physical disk and your index sitting on another physical disk, or even tables can be separated by physical disk. And just keep in mind that multi-threading capability. So because of that, you can have SQL Server having multiple workloads running on different file systems. So let's talk about data files first. And just to clarify, a file group is a logical grouping of one or more data files. And every database has a default, which is primary, but you can add multiple file groups if you want. So data files use something called the round-robin proportional fill algorithm. And that's a mouthful. And I'll show you how that kind of works. I'll draw it out for you here. So because of that, you have to make sure that data files are equally sized. And they'll make a lot more sense once we start looking at demo. You also need to make sure that you pre-size your data files in advance. Growth operations can affect performance, especially during times of high transaction frequency. And when available or appropriate, you should use separate physical disks for your workload. In bigger systems, obviously, this is a lot more important. Disk is always going to be that bottleneck in your system. Disk is definitely not up to the speed of where RAM is, and probably not going to be for several years to come. You should definitely separate your transaction log and your TempDB files from your data files. Each of these sets of files should be on a separate physical drive, and you should consider this a requirement. For SANs, this means you should have them separated on different ones. So do not put them all together, not just for a performance perspective, but also from a disaster recoverability perspective. So let's talk about the round-robin proportional fill algorithm. So on the left-hand side here, I have somebody inserting some records. Now, let's draw somebody here. So I have two data files in this file group. One of them is, has it's 1 gig in it, and it's 100% free, so it has 1 gig free. The other one is 500 megs with 100% free, so it has 500 megs free. So what SQL Server does is it's going to proportionally fill this. So when this person inserts record 1, it's going to go to file number 1. When they insert record 2, it's going to go into file number 1 as well. Then when they insert record 3, it'll go to file number 2, and then record number 4 will go to file number 1. And the reason it does that is because this file has double the free space of this file. So because of that, it's going to do 2 inserts for every insert here. And this is not the best for performance. So let's go to this example here. And person number 2 has put their database in a different structure. So they have 2 files that are equally sized and have equal amount of free space. So what's going to happen is, as they're inserting records, these records are going to be distributed across these data files. So record 1 will go to file number 1, and then record 2 will go to file number 2. Then record 3, with a different color, will go over here, while record 4 goes over here. So it's proportionally filling these files. And that's a lot better for performance because it's going to balance the I/O at this point. Instead of doing all of the I/O on, or double the I/O on one file here, it's actually going to divide it 50-50 as it's doing inserts. So before I talk about TempDB, any pending questions I can answer?
How are physical disks managed in a VM environment?
How are physical disks managed in a VM environment? That's a very long question and a very long answer. So I would say let's leave that to the end if we have time. It's a difficult one to answer too. I'll continue. There'll be time at the end for questions as well, assuming we have time. All right, so let's talk about TempDB. So remember when you were a kid and you used to go to that communal swimming pool that everyone else went to? And there were a bunch of little kids that would go in and they'd do their business in there, right? So if you can remember that scene, now you're ready to learn about TempDB, because that's how TempDB is. It's a communal pool for a server. Everybody on that server is using TempDB. So TempDB needs to have multiple files. And that's because SQL Server has the capability to do multi-threading, right? So it can have multiple processes working at the same time. When you have multiple threads over one TempDB file, you have a lot of contention. So there are these internal system pages that are part of every data file, GAM, SGAM, and PFS. So these internal pages basically help SQL Server allocate or track space for objects such as tables. So when there's contention, there's going to be performance impact. Now, this is kind of what it looks like. And I'll try my best to draw here. I'm a really terrible artist, but I'll try my best. So let's say you have TempDB, right? And this is also, this applies for regular user databases. But TempDB is the one that has more contention because it's being used regularly by all users of the instance. Because every time you create temporary objects, it's going to go to TempDB. So you have these internal pages in here, GAM, SGAM, PFS, and they store a bunch of interesting information about the data file, about free space, and so on and so forth. So let's say that you have a user trying to get a table allocated. So what they're going to do is they're their request is going to go to TempDB. This is a temp table, and that request is going to lock, one or more of these pages, and then allocate space for that person's table. So as another person does it, and their request gets sent to TempDB, they're going to have to wait for that person's request to be completed, because they need to get a lock on one of these internal pages so that they can get their object allocated. So once they're done waiting, they can get a lock, and then they can get a page allocated to them in TempDB, or an extent, or whatever they're looking for. So when you have multiple files for TempDB, what this does is it reduces the contention. So let me draw another person here, get another color. Running out of colors. So person orange is trying to get their object allocated. So instead of having to go over to file number 1 here for TempDB, they can go to this file and get a lock on this page, and then get their object allocated, and then release the lock and allow someone else. So when you have multiple files, it's going to reduce the contention on those internal pages. So even if you don't have separate physical disks for TempDB, just having them on one physical disk with that logical separation is going to increase your performance, because the internal structures are not going to have as much contention. Clear that up. So kind of the rule is to start with 4 or 8 files and not to exceed 8 files unless needed. I had a discussion with the SQL Server MCM, our SQL Saturday about a month ago, and he mentioned that, his name is Jason Brimhall, he mentioned that 24 files for TempDB is that sort of max that's been tested, where you don't get as much return for what you're putting into it. So just adding more, or one file per core, as was the advice in the SQL 2000 days, is not going to be as efficient now. You have systems with 64 cores or more even. I've worked with systems that have 128 cores. So that doesn't mean you should have 128 files. So you should definitely do testing. Start with 4 to 8 and see how things work with you. You should also pre-size TempDB according to your workload. So let's say, for example, that you do patching once a month. So just see the size of your TempDB for that month, and then make sure that your TempDB is pre-sized to that size, so that every time you restart the server after patching, TempDB is going to pre-allocate that space on disk. So as I said before, growth operations can be costly. So you want to make sure that you pre-grow it so that there's no growth operation when there's high load on the system. And finally, you want to make sure that you test everything. Don't just take my word for it. Start with 4 to 8 files and start testing and see how your performance improves. And now that you know how to use the PAL tool, you can start to use that to compare your baselines against each other. So let's go on to a demo of TempDB and data files. Close all this out. All right, so this is basic script you can find anywhere that you can search on the internet for. It's to alter TempDB. So this first one is going to alter. TempDB comes with one data file out of the box, and the rest you have to create. So this is going to alter my primary data file. It's going to alter the size and the file growth. And these 3 commands are going to add 3 more data files to TempDB. So I'm not going to run this because I've already done it on my server. But it's very simple. Also, I'd recommend you do this during the maintenance window and make sure that you have the paths set up properly. Otherwise, when you restart SQL Server for this change to be implemented, you're going to have problems getting that server to start. All right, so let's talk about multiple data files. So I'm going to create a database here, and I run that drop command. Okay, no, sorry. So I created this database, and basically it has 2 files. And let's pretend that file number 2 is on a separate physical disk. It's not, but let's just pretend for this demo that I created it on a separate physical disk. I'm going to set the recovery mode to simple for this demo, and I'm going to create a table with a bunch of garbage data in it, with the exception of my name. My name is not garbage. And I'm going to run this query here to show you what it looks like. So I have two files, both size 3 megs, and this is the number of free space and the number of free pages and free space in megabytes. So what I'm going to do is I'm going to initially load this with about 1,000 records because I want it to grow. And then I can start to show you what it looks like afterwards. Okay, so I have two files here. Row number 1 is file 1. Row number 2 is file 2. This is log file. You can ignore this. And both of them have 0 free pages and 0 free space. So I'm going to run this insert command. And what's going to happen is this data file has grown. It went from 5.125 to 5.25. It has 8 free pages and 64 KB. When I run this command again, you'll see that it has 0 free pages, has not grown in size. And when I run it a third time, this file still has 0 free pages. However, file number 2 has grown, and now it has 8 free pages because I did an insert. So it's grown 128K, and now it has 8 free pages, which is an extent, because every insert that I do inserts 1 extent's worth of data. So I run this again, and I'm down to 0 free pages. So as you can see, for every insert, my file is growing, and then it's taking data, and then when it's full, it's going to grow the next file, and it's going to take data, and then it's going to get filled and grow this file. So you can see that it's proportionally filling. However, it's not growing both files at the same time. So with this trace flag, so it's 117, it's safe to use. This trace flag will grow data files together that are in the same file group. So when I run my insert again, as you can see, both data files grew. And when I run it again, well, you run it a couple times here, you'll start to see that both of them are filled. They're at maximum capacity with 0 free pages. And when I run the insert, both of them grow at the same time. And then SQL Server will start to proportionally fill them. So it'll start to insert into file number 1 because it has more free pages, and then it'll go to file number 2, and so on and so forth. As you can see, when I ran it, this went from 16 to 8, so now it's even with the other one. When I run it again, this one goes to 0, 8 free pages. Run it one more time, now they're both at 0. Run it another time, and both files grow together. So that's the proportional fill algorithm in a nutshell. So let me add a second file group here, and I'm going to add 2 data files to it. So now I have a second file group with 2 data files, file number 3 and file number 4. And let's pretend that file number 4 is on a separate physical disk as well. I'm going to create the same table that I created, but I'm going to create it on that second file group. Right? I'll show you what that looks like here. So now I have file 1, file 2, file 3, file 4. These two are in a separate file group, and the table I created is on that secondary file group. So I'm going to insert a bunch of data, and now I'm going to show you what that looks like. So as you can see, file number 1 and 2, the current size has stayed the same. File number 3 and 4, the current size has increased. And every time I insert, if you notice, file 3 and 4 are being affected, but files 1 and 2 aren't. Right? So now it's down to 0. Free space is 0. And when I run that again, both of these files have increased in size, whereas file 1 and 2 have not been affected. So I've effectively made my new table write data to files 3 and 4 and not to file 1 and 2 because I've created it on that new file group. So with this in mind, you can actually separate your workloads. If you have a table that you know has a lot of inserts, for example, you can separate it on a different file group that's on faster disk, as an example. You can also do that for indexes as well. So I'm creating a third file group, and I'm going to create another file on there, and I'm going to create 2 indexes, really bad indexes, on my first table. So my first table is on file group, well, it doesn't have a name, it's just called the primary file group, and files 1 and 2. There we go. So here's file 1 and 2, and my index is on a separate file group called index.fg, and that's also the name of the file. So as I insert data, you'll notice that rows 1 and 3 will change because data is being inserted into the table, as well as row number 6, because indexes, they store data as well, right? They store data about your table. So I'll run that, and you'll see that the data has changed in files 1 and 2 and on the index as well. So what I've done is I've effectively separated my index onto a different store. There's a caveat with doing that. Doing recoverability, having your index separate from the data file could cause some recovery issues if you're unable to get that index, restored or whatever. But I've effectively separated my index from my data, so that can also help reduce contention on disk. One thing to note is that I created these indexes as non-clustered indexes. If I create a clustered index on a different file group, what that's going to do is that's going to move the actual data to that file group, because the clustered index is the actual data file. So just keep that in mind. All right, let me go back to my slides here. I might ramp up the speed a little bit since we're getting close to time and I still have another demo to do. So let's talk about those acronyms, specifically IFI, which stands for Instant File Initialization. So what is it? It basically prevents the database from zeroing out or zero filling upon creation and growth. That probably means nothing to you. So let's see what that looks like in the diagram. So this is your hard drive. It looks wonderful. And when you hit the delete command, this is what happens. When you hit the delete command, the operating system goes in and it says, hey, this space is available for reuse, but the data in there is still there. It still exists, and that's why people can recover data that you've deleted. But when you do what's called a file erasure, you can use a program like Eraser or something like that. It actually overwrites that data with zeros or whatever it overwrites it with, whatever algorithm that software uses. So inside SQL Server, there's something called IFI, Instant File Initialization. So here, IFI by default is off, and it is a setting that you set on the operating system. And what that does is every time you create a database or allocate space, it's going to write zeros on the disk. Okay? Whereas if you turn Instant File Initialization on, what it does is it just takes a piece of disk and allocates that disk to your database. And what that means is that if there's data here, it doesn't overwrite it. So as your data is being written, it does overwrite it. So as you grow your data, it's going to write zeros to that space that it's growing, whereas with Instant File Initialization turned on, it's just going to allocate that space. So why is this useful? And why am I wasting your time with this? Because it makes database file creation and growth faster. When the operating system has to write zeros to disk, it's taking time and space to do that. So imagine you create a 10 gig database file. It has to write 10 gigs worth of zeros onto disk. Whereas if you have Instant File Initialization turned on, it just allocates that space to your database file. So that means that creating database files is faster. it also means that rebuilding TempDB is faster. So every time you restart your server, TempDB rebuilds from scratch. So if you have a clustered SQL Server, FCI, when you fail over, having instant file initialization turned on is going to make it start up faster, because TempDB now can be recreated without having to do all that zero writing onto disk first. So the question is, who doesn't want a performance boost, right? Although someone could potentially break into your data center, drag all your disk drives out of there, and then figure out what was on disk because they haven't had any zeros written on them, that is a warning that I want to give out there. But that's highly unlikely. So there's really no downfall to this. It only affects data files. It does not affect log files. So just keep that in mind. And that's why I'm mentioning it here before talking about log files. It doesn't work with CDE, transparent data encryption, and there are a few other rules. It's very easy to set up. I'm not going to go over all of these rules. The slides are available. Oops. And it should be quite easy to follow this. And when I go back to my VM, I'll show you real quick how to get to that. It's just a setting that you flip. All right, so let's go on to VLFs. And I'm sorry to rush through this, but I still have a lot of content to go through, and I hope to get it all done. So VLFs stand for virtual log files. They are an internal logical structure for log files. Just like data files have some internal, pages like GAM, SGAM, PFS. VLFs also have an internal structure. Log files have an internal structure called VLFs, virtual log files. And these can cause major performance problems. If you have too many VLFs, you're going to have slow restores, slow inserts, slow updates, deletes, and it can also be a sign of a fragmented log file, meaning you've had a lot of growth operations on that log file, and now the log file is dispersed along the disk. It can also cause excessive locking. It can slow down your high availability features like mirroring or availability groups, maybe even replication. And if they're too large, if the VLFs are too large, T-log backups can be slow, and they can take longer to clear. So just something that you need to be aware of. Don't worry though, they're easy to detect and easy to solve. You just need to do pre-sizing of your log files, and you need to size them using regular intervals, not using a percentage. There's a command called dbcc loginfo. It returns a number of records, so when you run this, it returns a number of rows, like 100 or whatever. That number of rows that it returns is the number of VLFs for that log file, for that specific database. It's an undocumented command, but is pretty well known. So let's look at this log file and kind of dissect it here. So this is a transaction, has a start time and an end time. So as that transaction's running, this VLF is in use. Okay, let's put a circle here. So if you run a log backup here, transaction log backup here, this VLF is still going to be in use. But let's say that the transaction's finished. What's going to happen is it's going to mark this VLF as available for reuse. So when you run a transaction log backup afterwards, it's going to mark this entire VLF as available for reuse. So let's say that you have a couple transactions here. Pick a better color right now. And you're running all these transaction log backups. Obviously, as a transaction log backup is running, these VLFs are not going to be cleared until the transaction is complete. So let's say you have all these long-running transactions and you're running log backups regularly. These log backups will not clear this VLF until all transactions are completed that have started in that VLF. So the log backup at this point will clear this VLF here. We'll mark it ready for reuse. Okay, so far so good. Now, what happens is, if you're not doing if your transactions are long, excuse me, and you're not doing proper log backups, what happens is the log file is going to reach its endpoint. And what that means is that one of two things. If you've been, a good boy or good girl, and your transactions are short, and your VLFs are being marked as available for reuse because you're doing regular transaction log backups, so it's clearing it. What's going to happen is the transaction log file is going to loop around and start from the beginning and start writing transactions here. Now, if you're not doing proper log maintenance or your transactions are too long so that you can't clear the VLFs, it's going to start growing that log file. And it's going to keep growing. And as it's growing, it's creating more VLFs internally. And on the next slide, I'll get to the number of how that looks and how many and so on and so forth. So your log file works in a circular fashion. So you want to make sure that your transactions are short. You want to make sure that you're doing regular transaction log backups in the full recovery model. In simple, all this VLF stuff is done automatically. All right? So just keep that in mind. And as these VLFs are being marked for reuse, and when they're starting to be reused, SQL Server is writing zeros on disk. Remember we said that IFI, instant file initialization, does not affect log files. So as you're growing these log files, it's going to have to write all these zeros before it can start to be used, which is a good primer for pre-sizing your log files. So if you create a new database and you pre-size the log file, all that fancy zero writing is going to be done at the initial creation. So as you're writing transactions, your throughput's going to be a lot faster because it doesn't have to do that zero filling. So this is what my VLF looks like. This is probably what your VLF looks like, but definitely not as attractive. Your log file is going to be heavily fragmented if you're using auto-growth operations, especially if you're using it based on a percent and not a set interval of megabytes. So you need to pre-size your transaction logs based on your workload. And the growth and size determines the number of VLFs. As you can see from this chart, if you're growing less than 64 megs, you're getting 4 VLFs. If you're growing between 64 megs and 1 gig, you're getting 18. If you're growing 1 gig plus, you're getting 16 VLFs. So you have to make sure that, if you have a 10 gig log file and you're growing at 10 megabytes, I mean, you're going to have, thousands and thousands of VLFs, which is going to affect performance. And my demo will show that a little bit more. And you may ask, well, how many should I have? And the answer to that question is it depends. Too few large VLFs, the log backups take longer. So Kimberly Tripp, who's the presenter for next month, has a great article on SQL skills where she discusses this. And I would recommend you to look at that. So you shouldn't really exceed 512 megs. There's a couple other rules, but for time's sake, I'll skip over going that. And if you have too many small VLFs, you have longer recovery time. You may have locking issues. So the rule of thumb is, don't exceed 300. 100 is a good number to have, and it also depends on the size of your workload as well. I mean, if you have huge transaction logs, you may need to have more VLFs so that you don't have them larger than 512 megs in size. So let's go to a demo. This will help solidify the information, hopefully. So I'm going to put this trace flag on, and what that does is it shows how instant file initialization is affecting my growth operations. And just quickly here, you go to Control Panel, Administrative Tools, Local Security Policy. If you go to User Rights and Assignments under Local Policies, there is something here called Perform Volume Maintenance Task. So what you need to do is you need to add your SQL Server service account to this group, and that'll turn on instant file initialization. All right, So let me cycle the log here. So I'm going to create a database called GoodVLF. Basically has a log file that's 800 megs in size with file growth set to 100 megs. So as you saw, that took approximately 4 seconds to create, and that's going to be important for us coming minutes here. So I have 8 rows returned from running dbcc log info command, which means that I have 8 VLFs. They're each approximately 100 megs in size. Not sure why I put that in there, but they're about 100 megs in size. 800 divided by 8 is 100. Now I'm going to create another database called bad VLF, and I'm going to create it with the default size of 1 meg and file growth of 10%. This is like the default that you get out of the box. And you'll see that that didn't even, barely took 1 second to create, right? So the first one took 4 seconds because it's pre-allocating that 800 megs in size, and because it's pre-allocating that size, I'll show you here what it looks like. Because it's pre-allocating that size, it's writing zeros to the disk, so it's taking a little bit longer. So you can see good VLF is 800 megs, and bad VLF is 1 meg. So let's see how that affects performance. So first thing I need to do is I need to set both databases to full recovery, and I need to do a full backup. If you don't do a full backup after setting your database to full recovery, it's not going to behave like the full recovery model. So this is just a trick that people use to back up to null, which means just run the backup operation but don't save anything to this. Just for demo, don't do it for production. Before I move on, I wanted to show you the number of VLFs for the bad VLF database. So there's 4 in here, and they're about 256K each. This is also a nice command, dbcc SQL perf with log space and parentheses. It's going to show you the space used for your logs. So this one, good VLF, has less than 1% used, whereas this one is 55% used because it's only 1 meg in size. So let's create some dummy data here. I'm going to create a table. I'm going to create a clustered index on it. And I'm going to start creating some data here. And this code, what it does is it does some inserts, and then it does an alter index, and it does a delete, and then it does an insert, alter index, delete, so on and so forth, until the transaction log fills up. So the reason why I put an alter index in there is to demonstrate that maintenance commands some of them have logging, so they do log to a transaction log. Wow, so just keep that in mind. A lot of people think that insert, update, delete is the only thing that affects transaction logs, but that's not absolutely true. There are a lot of maintenance tasks that can affect your transaction log. It will take a little bit of time to run, so if we have any questions, I can take them now. Don't be shy.
What is the minimum amount of virtual logs that a log can have?
Good question. I think it's 4 or 2. I remember reading about a growth operation that can create 2 VLFs, but I don't have much info on that. Again, I would recommend the SQL Skills article by Kimberly Tripp for more information on it.
And this is going back a little ways. How would you rebalance the data files when adding files after the database has been created?
How would you rebalance? Wow, it's a really good question. It's a good interview question. How would you rebalance? So you can grow the databases even if they're in use. You can use the alter database command to grow them. And in doing that, let me write this down. 48. And then you start this one up. It's going to take a little bit of time as well. So in resizing them, initially you're going to give the database more space, and then they'll eventually get caught up. So let's say that you have two data files. One is 500 megs, the other one is 200. Say that you grow them both out to 1 gig. They're going to start to, one's going to take more records than the other because it has more free space. And then eventually, once they hit the 1 gig mark and they grow together, then they're going to start to proportionally fill together in the future. So it's something that, the other way to do it is to create a whole new database and copy everything into there, which might not be the best thing to do. So.
How do you reduce the number of VLFs?
But we're getting there. We will get there. So my second query that I'm running the exact same query on my bad VLF database, which I did not pre-allocate and did not, get any, TLC to. So it's going to take a little bit longer because it's, as we're talking right now, it's actually growing that log file. Like you can see that that log file is growing right here. Went from 500 something to 600 something megs. And eventually it will stop. Whereas my other file here, it's always maintained the same size because I pre-grew it. So this one is 700 megs in size, this one's 800, and as you can see, they took about the same amount of time to complete. This one took a little bit shorter time. In my test, it's usually taken a lot longer to do the second one. So the log file has grown to about the same size as the other one, but it's taken a lot longer. And it also has a lot more VLFs. It has 68 VLFs, and they're not evenly distributed. So you can see the size is a lot different as I'm scrolling down here, and that's because I used a percentage. So what do I need to do? I need to shrink that log file. I'm going to set to simple recovery. I would not advise you to do this in production. What I advise you to do is first, take a maintenance window. Second, practice this in development first. And third, I would take a log backup before doing this. So I'm just setting it to simple recovery so I can clear the log out. And what I'm going to do is I'm going to shrink the file, and then I'm going to start to run alter database commands, and I'm going to start growing that file manually. So this is the way to resolve issues with a lot of VLFs. You grow that file manually. So I've grown it in 4 different increments, and this last command is going to set the file growth to an increment in megabytes and not in percentage. So that's how you would solve that. Now let me go to another example where you'll see that those two log files are pretty close in number of VLFs, but this example has a lot more VLFs. And I had to pre-create it because it took a little bit of time. So I created a database called FireMe VLF, because someone should be fired if they did this. And the size for the log file is 1 meg. Max size is 400 megs with a file growth of 1K. I already created this. I already ran the backups, and I created a similar table, and I inserted data into it, and I just did some inserts and until basically the log file filled up. Because I set the max size to 400, my log file filled up, and it created, took about 28 seconds. Let me note that down, 28 seconds. And it created a bunch of VLFs. It created 1,600 VLFs. Okay, so that's a lot. Even though they're evenly sized, that is a ton of VLFs. So I'm going to create a second database here called FireMe2, which is going to be the good one, so I probably shouldn't have called it FireMe. It takes about 4 seconds or 2 seconds to create. I have 2 different demo environments. This one's a little bit faster. Whereas this initial database that I created with a size of 1 meg took, very little time to create. So I'm going to run a backup for this one as well, and I'm going to create the same table I created for the other database, and I'm going to do this insert, which is going to fill my transaction log. And once it's filled, let me go here, is going to crash out my system. So
FYI, we're actually out of time, so if you want to kind of wrap it up.
Okay, I'll try my best. Can I get 5 minutes? Silence is acceptance. All right, so I created a second log file here, and I've maxed it out. It has less VLFs. It's actually taking a lot longer than it usually should. So my first one, generally when I test it, it takes a lot longer time to create than the second one. So I'm going to blow through this here. I'm going to run transaction log backups here on my first database. It took about 4 seconds. And then transaction log backup on my second database here. It took 2 seconds. So it took half the time to run on the second one because it's pre-allocated. It has a lot less VLFs, so it's easier for SQL Server to manage. And in the last demo here that I was going to do, I was going to create 2 open transactions and then turn the databases offline and then bring them online. And the database with more VLFs would take longer time to come up than the database with less VLFs. So it just kind of, my proof that having a lot of VLFs can affect performance, but we'll have time to go through that. So the last thing I'll leave you here is there's a lot of other considerations for performance tuning. A lot of these considerations are what I call kind of transparent, so you don't have to make a lot of application changes, like indirect checkpoints, for example, buffer pool extensions, in-memory OLTP. Well, that may need a little bit of changes on the database size, but indexing, performance tuning indexing, table partitioning, even setting some of your databases to read only that are doing nightly ETL loads. All of those can effectively improve your performance of your database. And also avoid thin provisioning of virtual disks. So someone asked about VMs. Do not do thin provisioning. Thin provisioning means that they tell you they gave you 100 gigs, but they just gave you the theory of 100 gigs. You don't actually have 100 gigs allocated to you. So that's something to think about. And compression can also help performance. So that's all I have. Happy performance tuning. If there are any questions, if we have time, I can answer them. If not, our great hosts here will send them by email, and I'll try to answer them in a blog post.
Thanks, Iman. I really want to thank you for sharing today. Your incredible knowledge is always a great presentation for our chapter. Our winner today of the Amazon card is Greg Jackson, and we will get in touch with him so he can get the $25 gift card. Wanted to remind everyone that this session has been recorded and will be available in our archive session within a week. Also, Iman will send us the slides and scripts, and you can also probably go to www.thesequelpro.com, and he should have a lot of this stuff on there as well. I want to thank everyone for coming, and please remember us on the 20th and come back and hear Kimberly Tripp. Thank you.
Thanks for having me.